So we're going to translate verbal expressions into algebraic expressions today. So our goal is to translate verbal expression into algebraic expression by analyzing the appropriate words associated with specific mathematical operations. So let's review a little bit. Can anybody tell me what a numerical expression is, or give me an example of numerical expression, Alana?
Numerical expression like 3 plus 2 equals 5.
Oh, that's not become expression.
Just no, expression is without the equal sign.
Yeah, just 3 plus 2. Anybody else? Give me one more. Urain?
Yeah, expression is like a numerical
give me one.
Expression.
Give me example.
Is like 5 plus 10.
That's okay. You guys only know addition?
5 plus 10.
You guys only know addition? That is sad. Give me something else than addition, please.
Or addition divided by 10.
That's okay too.
What about
1,000 divided by 2.5?
Or anything divided by a number. So let's say 5 divided by 2. That's another numerical expression. All right.
Second power plus.
Yeah.
No, that's algebra.
Oh, actually, 3 to the power of 2 is a numerical expression. It's just numbers.
Yeah, because it's just that.
All right. So let's move on to the next one.
You can do fast.
Let's go to algebraic expression. Give me an example of algebraic expression, Selena.
May I do one?
Selena, go ahead.
Okay, so let's see. 3 times 2 parentheses plus 10 divided by 2.
That is a numerical expression.
Oh, like algebraic expression leads to.
What is? Let's go. Let's talk about it. Wait, let's talk about it first. Algebraic expression. Wait, one at a time. Omar, what is an algebraic expression?
I'm not sure, but I think an algebraic expression is that when you have use the letters for representing something. So correct. For example, M plus P and then parentheses.
Oh,
give me too much. Omar, M. Wait, one at a time, Selena. M plus P is enough. Give me another one, Selena. Go ahead.
X plus 2 equals 6.
Stop right there. Stop right there. You should not be saying the word equals. Yeah. Tiffany, go ahead, Tiffany.
X times Y.
So XY. Urain, one more. Okay. Go ahead, Urain.
P to the 5th power.
The only letter you know is P now, huh? Oh, Alana, go ahead.
A to the 25th power.
Okay, so that is example. These are example of algebraic expression. You know, guys, that x over 2 is also an algebraic expression, a division one. What else are we missing? So if you have 2x, 2x minus 3, that's also another algebraic expression. So these green ones are what we call algebraic expression. If you notice, it has variables and it has numbers together, not compared to the numerical expression, just numbers. Let's go to the next word we have. We have the word term. A term is separated by the operations like addition and subtraction operations, and then it's combined with multiplication and division operations. So if you know an example of term, can I have one, please? Alana.
So I'd say 5 to the 2nd power. 5 would be the term.
So you just want to give me a numerical expression, a term, that's fine. No, the entire thing, 5 to the power 2, is the entire term. So another one, I'm just going to give it to you guys so that we'll not confuse ourselves. So that's 2x. 2x is 2 times x. That is written as 2x without a dot. Later on when we go Savas, it's going to show us an example. So that's an example of one term. If you have x over 2, that is another example of one term because it's just not separated by addition or subtraction.
Wait, so a term is just like one thing?
Yeah.
So for example, 6 to the power 2 is a term.
Yeah, that's a term. That's a term. That's a term. If I have x plus 2, these are two terms. X and 2. So a term.
Is a term the number or a variable or a product of numbers, variables, and or expression?
It's actually
so digits. So all
like,
the digits are terms.
Yeah, for example, So let's, for example, go back to the little green one. So m plus 3 are terms. Are two terms, I mean, but one expression. So x plus 2 is an expression with two terms. xy is an expression with one term. So if you have, for example, 2x, I'm just still gonna do this, minus 5. These are an expression with two terms, 2x and 5. See that? That's a term, but it's just a number. This is a term that is combination of the product of 2 and x. This is a term, a quotient of x and a number. Two terms, x and a 2 and a number. 2x minus 5 is also two terms. So again, terms are separated by addition and subtraction. It is combined with multiplication and division. We'll deal with more of that. And the variables are letters from A to Z. So it's up to you which one you want to use. It doesn't end with XYZ.
Don't you not use O?
It's up to you what you want to use.
Shouldn't you not use the letter O because it looks like a 0?
So good that you mentioned that. I usually avoid X, T, and O because that looks like something else, So we avoid X to multiply because we use that mostly as variables. We eliminate that as operation. Exponent, we know.
That's why they usually use cursive for X, T, and
yes.
We
use
so then we know the difference.
We use something like that.
But then
yeah, so good for that. All right, so constant, let's say for example I have 5x plus 8. All right, so with that, what is our constant? Anyone?
5. Is 5 the constant because it's the term with an expression that doesn't change?
Oh, you said exactly the meaning of constant, but if I put 3 on the x, that 5 will change.
So then is it an x?
The x is a variable.
Alana, repeat what you said before.
The 8 is constant.
Yeah, a constant is a term that in an expression that does not change.
So 8 doesn't change. 8 will always be 8. But if you put 2 as a value of x here, then 5 will change to 10. So 5 is not constant, but what is the word that represents 5? Start with letter C. I'm typing it.
Coefficient.
Yes. And then we know that the x is the variable. And these are two terms, 5x and 8.
Is the coefficient the factor of a variable term with an expression?
Correct.
And it's the number that's multiplied by the variable?
Correct. That's correct. I take a little picture of that. I'll give you like 30 seconds to take a screenshot. I just wanted to answer the first two before the end of the school year. All right, so let me see what are our answers. So 30 minus 3 plus 2. Quinn has 30. You bought a notebook for 3 and a pack of pens for 2. So you take away the price. That's right. Colleen runs 3 miles twice a day for 30 days. Twice a day for 30 days. Can we consider it for exponent?
Ms. Nora, for for my screen, it doesn't show the third
You're
question.
choppy. No, we don't need third question. Oh, because I edited that. There's no question. What is the difference between this one? Where is? Oh, the change it. Why did you change it? That was a good one. 3 to the power of 2 times 30 and 3 times 2 times 30. Because it just say twice, right? Twice, 3 miles twice a day. So it's just times 2, not to the power of 2. All right, so a little review of that one, writing expression, we're good. So let's proceed to our next one. Here, I want you to write, see, I thought I edited this. I want you to write words that may represent each of this. So it could be, this could be a multiplication, and this could be a division, and this could be a subtraction. So just talk about it then, so it will be fast.
On my screen.
No, you don't need to.
On my screen, it says
it's okay.
Addition, subtraction, multiplication.
I know, that's why I changed them. Or in your screen, it means you got the edited version. I don't know why I don't have. I don't know why I don't have the edited version. Okay, give me a word that may represent addition, please. One word alone. Add. Omar, one word. You
Add
say
or
together, or you could say all
Some.
together.
Put more, maybe.
More. Some. What else? Keep going.
in all.
Huh?
In all.
In all. Total. Anybody else? We still remember the word deposit. We did this before. Profit. Anybody else have more words? All right. For subtraction, give me some words. Jin, words.
I had a word for addition.
What is it?
Inclusion.
Inclusion? You say inclusion?
Yeah.
I would add increase, decrease.
Oh, can I have a word for subtraction?
Yes, go subtraction.
Withdraw.
Withdraw. What else? Withdraw.
Negative. Take away.
Take away.
And the difference.
Oh.
Difference.
Difference.
What else?
Difference.
What else?
Oh.
Oh.
Like you owe someone money.
Yes, that's true.
Minus.
Minus, definitely.
Decrease.
What is it?
Decrease.
Decrease. All right. For multiplication, give me one.
Product. Repeated addition.
Product. What else? There are a lot more, guys. Just a little review. Product times, of course.
Selena said repeated addition.
Repeated addition.
Multiply.
Multiply. What else?
Does exponents count as multiplication?
You say power, yeah. Or, oh, in my previous guide, they say double. Reduction. Reduction, I don't think that goes for multiplication. I think that goes for subtraction.
Yeah,
Right?
reduction means like,
Yeah.
I don't know.
How about divide?
Yeah, divide. Well, divide, but division. Group. Does
Group.
count? Break up.
Huh? Break up. Just break apart. Break up is so sad. I just
Separate.
separate. It could be used for both. It depends. It depends on how you use them. So I will not take it. But because you could use this for division or subtraction. Split.
And could you just separate into groups?
Yes, you could do that. Separate into groups. Split. All right.
Quotient.
Quotient. All right. So those are 1 or 2 or 3 of the words that we could associate with operations. All right. Just a little bit because we did this before. Okay. So you don't need to take a picture of that. We already know. It's just a little review of that. On the next slide, we're going to compare the first terms, or the first and the second term together. If we, in algebraic expression, if you see the word than, into, and from, and to, the comparison will switch. So just again, than, into, from, and to. So let's say, for example, I have this expression. Now I lost my two other examples because I don't know why I don't have the edited one. So it says, if you see here, there's the word than. And you say 5 less. 5 less means minus 5. And then a number is n. Could be B, could be C. But since it's the word than, it's comparing the other term to the other one. So instead of writing negative 5 plus n, we're going to write this n minus 5 because it says 5 less than a number. So you're comparing it to the number, the 5 less. All right. So again, the other example that we have is we have the word 2. So 10 added means that's plus 10, right? And then a number is just the n. And then since that word is a comparison for the second to the first, so we're going to write n plus 10. And another word is from. So the from is another comparison number from the second to the first term. So a number subtracted from 7. So a number it's subtracted is minus n. So we could write this 7 minus n because it's subtracted from 7. So from that we subtract n. Another word is 2. So 6 added to a number. So a number, I'm gonna add 6 because that's what it says. I have to add 6 to that number. But if you have something that says 10 increase by a number, it's straightforward, right? 10 increased by a number. So you could just say 10 plus n. So it's only these 4 words that will give us a little cue word or clue that we have to compare it to the other side. Especially when it's a negative number, it's really important to know which term should be written first. For addition, it doesn't matter because n plus 10 is also equivalent to what? 10 plus n.
10 plus n.
So what kind of property is that again, if you still remember?
Commutative.
Isn't it the property that you reverse it?
So,
I think.
A commutative
A
property.
commutative property, that is correct. So that will not work for n minus 5 because if you're gonna say 5 minus n, then the answer will be wrong. So it is okay if it is in addition that or multiplication, but not on division and subtraction. Okay. All right. So moving along. So we're just gonna check Sava's what activity is in there for us. Let's see.
How can you write an algebraic expression? Let's look at an example. Darius bought some comic books. How can you write an algebraic expression to represent the total cost of the comic books? What information is missing? The exact number of comic books Darius bought. Use a variable to write an algebraic expression. A variable is a letter or symbol that represents an unknown quantity. Let n equal the number of comic books. Each comic book costs $4. How does the table model the problem? The table shows the operation and factor used to find the total cost for any number of comic books. What does 4 times n represent? The cost of n comic books. An algebraic equation is a type of math expression that has at least one variable and at least one operation.
I would like to check that we could use algebraic expression. All right, just stand corrected. Jen, you could get out of the Peer Deck.
The total cost of n comic books can be represented by the algebraic expression 4 times n. What numerical expression shows the cost of 3 comic books?
Select your answer.
So which one? What will be the value of n that represent that?
4 times
4 times 3.
Alright, we'll take that.
4 times 3. How is an algebraic expression like a numerical expression? Both have quantities connected by math operations. How is it different?
Anybody can tell us? How is 4 times n? See, that's why I don't want to use the x anymore, because that represents variable x. How are they different? Let me see who is in the raised hand, because you guys been raising hand forever. All right, so I'll take the last one. Omar.
4 times n is different from 4 times 3 because n is not a numerical. It's not a numerical number.
Alana. Okay, go ahead. You're still talking, Omar?
Yeah, I don't think you can. Can you hear me?
Yes, I could hear you.
Okay, I'm done.
All right. Alana, would you like to add something to what Omar said?
They're different because why they both have 4, one of them has a variable, while one of them is an algebraic expression, while the other is a numerical expression.
Would you like to add something, Selena?
Yeah, I agree with all of them.
Urain?
I would like to add on, for example, 4 times n is not that clear, it does not have that much information, and 4 times 3 is clear.
I think what Urain is trying to say, yes. I think what Urain is trying to say is 4 times 3 is straightforward. We know that n is 3, but in 4 times n, we don't know what n gonna be. So it could be any number that you could think of. Okay, so let's continue.
Algebraic expressions use variables to represent unknown quantities. Numerical expressions do not have variables. All the information is known. You can also use a solid dot, parentheses, or no symbol at all to write the expression 4 times n.
4 times n, 4 times n, 4n, or 4n are all ways to write the same expression.
So, but then in algebraic expression, to write it neatly, I recommend writing 4n without the parentheses, without the dot, without the x. But it doesn't mean this is not correct. It doesn't mean they are not equivalent to each other. But a good way of writing it in algebra way is the last one, 4n. Okay, you're gonna try to work on later on page 2. So let me look at example 2. So here, let's listen to this one for a second.
How can an algebraic expression represent a given situation? An algebraic expression can use variables and operations to represent given situations. Part A, 5 minutes more than time, t. Part B, 10 erasers decreased by a number, n. Part C, n nectarines shared equally by 3. Part D, 4 times the quantity, x plus 8.
So for part A, what operation represents more than? The word more. What operation will that be? Can I have somebody else that was not that's not sharing for us for a little while? Let me see who I could ask. Annie, what operation this represents letter A? Addition, subtraction, division, or multiplication?
Addition.
Addition. Vicky, What operation that represents letter B says 10 erases decrease by a number n? Vicky?
Subtraction.
Subtraction. Briar, letter C. N nectarines shared equally by 3.
Division.
And the last one, 4 times the quantity x plus 8. Ayman?
Multiplication.
The first time is multiplication, and there's another one.
And then addition.
And then addition. Right. You guys are good with that. But then, Quinn, how am I gonna write an expression that represents the first one? 5 minutes more than the time t. How could I write an expression for this, letter A? Quinn, would you like to try?
I raised my hand by accident.
It's okay. Wanna try it?
No thanks.
How about Himanzi? I didn't hear from you today. Are you okay?
Yeah, I'm trying to do something. That's fine.
All right. So I'll be back with you. Briar, what will be your letter A? How do we write an algebraic expression for this?
5 plus t or t plus 5.
That's correct, but let's write it properly because there's the word done, even though it's addition, even though the commutative property applies. So how do I write it? Say it again. So you're gonna write it like what? How do I write them?
T plus 5.
Okay, so T, I'll put the T like that, and then I'll just put 5 small. All right, letter B. Let's go with Jen. Go ahead, Jen. This is just 10 erases decreased by a number n. So the word
10 minus 10 minus 10.
that is correct. The word by doesn't represent switch in comparison. Himandi, would you like to try letter C? N nectarine shared equally by 3.
And divide by 3.
So should I write it this way?
Yes.
That is also okay, but I really recommend that you write it in an algebra way, very neat, a fraction way. All right, but that doesn't mean that's wrong. That's also correct. But
Okay.
I recommend writing it in fraction way. How about letter D? Who would like to share? Let's see, Sarif, would you like to do that number 4? I mean letter D. So it says 4 times the quantity x. Can you give me the expression that represents letter D?
4 times x plus 8.
So the way you say it, erase the word times, like omit the word times. Say it again.
4x plus 8.
Perfect. 4x plus 8. There you go. So this is how we work on algebraic expression. All right. So I want you guys to go to Savas if you don't have any question and try to work on the expressions that give you. But I also would like to see example number 3. So are we good at this? This is recorded, so you could go back to the video if you want to go. Or if you want to take a picture of this, go ahead.